Okay, so sample exam 4, number 39, they give us a g of x function. It's defined as from 3 to x, 5 plus 4t minus t squared, and then 2 to the negative t dt. So that being our g function, the question says which of the following statements about g is true. So the first part says that the g is increasing on 3 to 5. So if it were increasing on 3 to 5, okay, then what would have to be the case with its derivative? The derivative would have to be positive on 3 to 5. So we know that from the fundamental theorem, our derivative of g here would be just 5 plus 4x minus x squared to the negative x. That part. So that is the derivative. So we could check that, see if it's positive on that interval. And let's go standard window here, see what we see. Alright, so in looking at the function, let's change our window a little bit here. A little too much. Okay, so it looks like between 3 and 5, 3 being right here and 5 being right here, does that appear to be positive? So let's go more specifically on 3 to 5 itself. And it looks like the derivative appears to have a 0 at 5 there. Okay. We could check that out and see if we go 5 plus 20 minus 5 squared, that'd be 0. So it does have a 0 at 5. And all throughout that region, the derivative is positive. So number 1, we'd say what? Yes. Alright, how about increasing on 5 to 7? If we change our window to from 5 to 7, we can see that the derivative has negative values. So would g be increasing on negative 5 or on 5 to 7? No. Alright, and then on the next part, it says g of 7 is less than 0. Okay. So g of 7 is less than 0. Now watch this. If we go to our, remember the function is defined from 3 to something. So if we were to stick a 7 in there, into the x there, we're going to get the area under the under our curve, okay, on that 3 to 7 interval. So again, if we go to the graph here, keep in mind that the g function is defined by the area of this curve in the x-axis. Okay. So we're gonna at 3. When we're at 3, we're gonna be accumulating positive area here. Right, and then when we get to 5, we're going to start accumulating negative area, but in terms of the actual area, which one's bigger? The positive area is bigger, so could it be safe to say that in number 3, it says g of 7, which should be negative? True or false? That one should be false because we're accumulating more positive area than we are negative, aren't we? That 3 to 7 interval. Say it again. 30.
Oh, my 1 off.
Yeah, 39 should be A, which is 1 only, which is what we said, right? Alright, questions on number 39. What else? On number 42, we have region R. It's enclosed by the coordinate axes and the graph of y equals k times x minus 5 all squared. K is greater than 0. And it says when this region is revolved around the x-axis, the solid form has a volume of 2,500 pi cubic units. So therefore, what is the value of k? So keep in mind that with the equation that we have here, okay, we're looking at this this region R that's defined by the k times x minus 5 all squared. And just if we let, just for argument's sake, we'll let k be 1 here and see what the graph looks like. Okay. Alright. And if we let k be anything else than that, so if we let it be, let's say 3, just for argument's sake, and it says that that k is positive, right? K is greater than 0. So again, just looking at another version of the same function with a different k. Okay, if we were to change the k value, all that's going to do is just make it thinner or wider, depending on whether it's a fraction or a whole number. I make the a value there smaller, like 1/2 or 1/4 or something. It's going to make it wider. And just so we can see that, if I just say I made it 1/4, just for argument's sake again. Have that. So ultimately, the key issue here, though, is what region are they talking about here? They're talking about the region that's enclosed by the coordinate axes in the graph here, and you can see it here pretty clearly on the quarter one. It's this region right here, isn't it? Because that's what's enclosed by the coordinate axes and the curve. So we're looking at that region right there. So bottom line here is, no matter what the k value is here, what's the a and b? We're going to be working with this region right here. Yeah, it's 0 to 5, isn't it? No matter what k is, the 0 is still at 5, isn't it? And we know that we're going to go from 0 to 5 because these are going to connect with the y-axis at some point, you know, up the line a ways. But bottom line is we're going to have an integral on 0 to 5 ultimately. So whatever the shape is here, this is our 5, and you know, again, whatever k is, we're going to have that sort of shape. So we're looking at this region right here. All right. And with that said, the question is, if we revolve that around the x-axis, which we can use a vertical slice for, we would get disks. And so our disk method setup would be from 0 to 5, and our radius of the disk would be the function itself, which would be k times x minus 5 all squared dx. And we know that that equals 2,500 pi cubic units.
Yeah.
Oh, sorry. Yes. Thank you. Alright, so not just an area, we're looking for the volume of that disk. So ultimately, our setup again is pi r squared. This is the radius of the disk. So we have that. And then from here, if we try to solve this, we know that we could divide by pi and get the pi's out of there, because they both have pi on each side. So we're doing the integral of this. If we rewrite this as k squared x minus 5 to the 4th, we square both of those things. We ultimately could bring the k squared out in front because the k squared is a what? It's a constant. So if it's a constant, we'll have k squared out in front. Well, the integral from 0 to 5 of x is minus 5 to the 4th dx. And nope, divide by pi on both sides. Goes out of there. Alright, so if we anti-differentiate the x minus 5 part, why don't we have to worry about u substitution here? Well, why didn't I have to, though? What is it about this argument that makes it so I don't have to worry about u substitution here? Josh?
The derivative of x minus 5 is 1.
Right. There's no chain rule issue here because the derivative is just 1. I mean, you can do u substitution, but guess what you're going to get? You're going to get x minus 5 to the 5th over 5. And we're doing that on 5 and 0. Alright. So, see what happens if we put in our 5 here. We're going to get 0, 5 minus 5. If we put a 0 in here, we're going to get 5 to the 5th, and 5 to the 5th is 3125 over 5. So it's really 5 to the 4th, so 625. Remember, it's negative 625 because of the fact that we put in a negative 5 into the 5th power. So ultimately, we get negative odd power, which works out good because then that makes it a minus minus situation, which we get a positive. So 625 k squared equals 2500 would be our sentence at this point. If we divide, oh, how convenient, we get 4, which means that our k would be what? Alright, and ultimately, how come we don't need to worry about the plus and minus when we do this? What did they tell us about k? Yeah, k is always greater than 0, so we don't have to worry about the negative 1. So k would simply be 2, and that would do it. Questions on that one? Alright, what else?
40.
On 40, we have another region that's enclosed by the line x plus y equals 1. And the coordinate axes, it's rotated around the line y equals 1, negative 1 that is, and what's the volume of the solid generated? So ultimately, if we draw our picture here, we'd have 1 as our y-intercept, down 1 over 1. If we solve this for y, we'd have negative x plus 1. So we'd have to ultimately have just that triangle. There's your line and your 2 coordinate axes. True? And we're going to revolve that around the line what? Y equals negative 1. So if we did that with a vertical slice, then our shape would be washers. True? So therefore our washer setup would be pi times 0 to 1. So going from 0 to 1 in the x direction here. Outside radius here is going to be the function plus 1. So ultimately the function is this. Plus 1 would be negative x plus 2 then. So the function plus 1. And the inside radius would be this distance from here to here, which would be 1. And that should do it. So let's see what we get.
Why do you do plus 1 function?
Again, we need the distance from here to here. That's the outside radius of the washer. So got to be from the outside of the washer to the revolving line. So ultimately, it's so the function gets you to the x-axis, and the plus 1 gets you to the minus 1 line. So if we got negative x plus 2, all squared, minus 1. It 4/3, so it'll be 4 pi over 3. Corresponds with letter D. What else? 41, we have function y equals sine x plus cosine x. And it says which of the following, so the function is a solution to which differential equation? Okay. Alright, so if we look at y plus dy dx equals 2 sine x. The issue that we have here is if we were to try to solve this differential equation and get from the derivative equation back to the y equation, I guess the question that we need to answer to ourselves is if I do this, I have these variables somewhat separated, but anytime I've done separation of variables, okay, I would have had to have had multiply by dx here to get that on the right side and have dy on this side. But if I were to multiply by dx, I'd have y dx here. I can't just multiply it by this part of that side. Okay, and so ultimately the separation of variables part is going to be a little bit difficult here in the fact that we have a plus here instead of a times. If this is y times dy dx, then we could certainly keep the y there and just multiply by dy dx, and we'd have our variables separated nicely. So I guess the bottom line here is there an alternative way to decide whether this is a solution to this differential equation? Okay. Well, ultimately, remember if these two sentences are going to be corresponding to one another, what would our dy dx be in our top equation? Sine x's derivative would be cosine x, and cosine x's derivative would be negative sine x. Okay. And ultimately, if these two sentences were a match with one another, and then this derivative, if I were to put that in here, we should get a true sentence, shouldn't we? Let's find out. We go y plus cosine x minus sine x equals 2 sine x. Okay. All right. And the other issue then is this is clearly not going to be an equality at this point. But what do we know about y here? Y is equal to what? Sine x plus cosine x. So if I were to plug that in there, sine x plus cosine x plus cosine x minus sine x equals 2 sine x. We would see that we'd have 2 cosine x equals 2 sine x, and that is what? That's not true. So therefore that appears that choice 1 there should be out. Okay, so let's try number 2. If we were to replace again, if we do sine x plus cosine x for the y, and then our dx is going to be cosine x, or dy dx, that is sine x, cosine x minus sine x. And this side we get 2 cosine x. Well, what do we know about this sentence? We already know that this sentence does equal 2 cosine x. And so, what could be said about number 2? Number 2 is good. That matches up. And then finally, what about the number 3? Dy dx here would be cosine x minus sine x. And then minus y. If I put that in parentheses, make sure you're careful and put that in parentheses. We're subtracting that whole y quantity. And then over here we get negative 2 sine x. So let's see what happens. If we do our subtraction here, we're going to get cosine minus cosine. Those are going to be gone. Negative sine x minus sine x is going to be negative 2 sine x on this side. And how does that match up with the right side? Good. So therefore it should be 2 and 3, which matches up with letter E. Any questions on that one? What else? Uh, 43 says y squared minus x cubed minus 15x squared equals 4. Says for what values of x does the curve have horizontal tangent lines? Well, if it had horizontal tangent lines, then what would be the case? The derivative would have to equal what? Derivative would have to equal 0, wouldn't it? So recognizing that this is an equation that would be easier to deal with implicit differentiation rather than solve for y, if we find the derivative here, we'd have 2y dy dx minus 3x squared minus 30x equals 0. And if we add the x stuff to the other side, we get 3x squared minus 30x. And if we divide by 2y, we get our dy dx alone. Right? So that being our derivative, if we set that equal to 0, what do we know about a fraction equaling 0? And this fraction would equal 0 when what? The top equals 0. So if we factor out a 3x out of there, at the same time we get x minus 10 equals 0. So 0 and 10 would be the 2 points where we have a derivative equaling 0. And you'll notice that in the choices that you have there, you have some choices, either 10, negative 10, 0, or some combination of both. True? Alright, so the question is, if we were to put x equals 10 in, we would certainly get a 0. If we put x equals 0 in there, we would certainly get 0. So again, those are candidates. So we got to decide, okay, which ones of these do we actually have horizontal tangent lines? Well, if we were to check our function, which was above, and again, I use the term function loosely. It's probably not even a function in some relation. Might not pass the vertical line test. Oop, you're right. Sorry. So that actually should be negative 10. There we go. Alright, so we added it to both sides. Thank you. So those two, again, would be our 2 zeros. If we were to plug each of these into our equation above, let's see what happens. If we were to put a 0 in here, we'd get 0 here, we get y squared equals 4. So y would be plus and minus 2. So on that curve, we would have 0, 2, and 0, negative 2 as our points. Okay. And if we were to plug those into our derivative, we'd have 0 on top and we'd have 4 on the bottom, or negative 4. Either way, they would give us 0 for the derivative, wouldn't they? Okay. So those 2 points seem to be good. All right. And again, remember, we're only looking for values of x. So the 0 seems to check out, which is good, because that is part of our solution. And let's check out the negative 10 just to make sure that that actually gives a point that's on this curve. So if we put our y squared minus, and we put our negative 10 cubed, minus 15 times negative 10 squared, we're going to wind up with y squared, and this is going to end up being plus 1,000. And this is going to wind up being minus 1,500. So we'd end up with y squared minus 500 equals 4. So y squared would equal 504. And of course, we'd get 2 y values out of that, which are totally legitimate as well. Okay? And again, if we were to put the 504, square root of 504 in here, 0 divided by it, it's going to be 0, which gives us, again, reason to know that we have horizontal tangent at that point. We have a point there, and we also have the derivative equaling 0 there. So therefore, it should be both of those. Match up with letter D. What else?
Could you put that in the calculator too?
We solved it for y.
For which part?
Like, say we just solved it for y.
And you could get everything on the same side, and you just have 2 different curves you'd have to do, y plus radical something and y minus radical, negative radical something. Alright, what else? 45 says which functions given below has an average value of 0 on the interval negative a to a, where a is greater than 0. Alright, so ultimately again we're looking for which of these functions has an average value of 0, okay, on an interval negative a to a. So let's think about the first function they gave us, which is the absolute value function. Okay. If we went from negative a to a, just for argument's sake, just say negative 2 to 2, okay, and we wanted the average value of this function, we'd find the area and we divide it by 4, and ultimately is that going to give us 0? What kind of function is it going to have to be if that's going to be the case, if the average value is going to be 0? So it would have to be an odd function, wouldn't it? And so in looking at our pictures here, cosine is not an odd function. E to the x is not an odd function. Sine x, which looks like this, is what? It's an odd function, isn't it? So if we did the average value, it would be the integral, which we'd have minus and plus cancel each other out and give us 0. So, and we know that cubic is not odd either, so the only odd one in that group would be sine. Anything else on the sample exam 4?
44.
44, we got a continuous odd function, it says. And it says the limit as x approaches negative infinity of our function is negative 3. And it says which of the following statements must be true. So thinking about picture-wise, we have negative 3 as our horizontal asymptote going this way. Okay, we know that our curve approaches negative 3 as we go to infinity. Okay. And we also know that this is an odd function, which means it needs to go through the origin. So ultimately, might have to look something like that, perhaps. Okay. And then we know also that if it's odd, then shouldn't we have this behavior going to the right? So going to infinity, the limit would have to be what? In order for this to be odd, the limit would have to be 3 as we go to infinity. True? Alright, so if we look at number 1, that's exactly what number 1 says. So if you give a yes there on number 1. Okay. A says there are no vertical asymptotes. Okay. So could there be any vertical asymptotes here? What's that?
It's continuous. So there are any vertical asymptotes, it's continuous.
Okay, correct, because it says it's a continuous odd function, so there's no way there can be any vertical asymptotes. And then, so that would ultimately be true because of the continuous part. And then 3 says the lines y equals 3 and y equals negative 3 are horizontal asymptotes. Well, yeah, that's true as well, isn't it? So therefore, in this case, all 3 would be true, so that should be letter E. Say not in my favor.
And you have no one.
I got E on mine. All right, questions? Anything else? Sample exam 4.